Hey everyone, Forging Station here. In the last video, we spoke about adding navigation capability to arbitrary entities. Those entities still did not know each other's position, hence did not exhibit collision avoidance, and this is exactly what we are going to do in this video. Though there are many ways to implement extremely good collision avoidance behavior, one thing I wanted to experiment was using the existing Boids behavior. The Boids system calculates bias-based forces of separation, cohesion, and alignment. We also have target bias, which acts as multiplier to the vector representing Boid's force of pull towards the designated target. In the previous system, this was just a fixed point. However, when we are navigating, this target changes for every waypoint. In other words, we have to update the target with the next waypoint as and when we consider an agent to have reached the current waypoint. I am using the latest entity 0.5 in the build, so we will need the partial keyword for all the systems we have. We will start by commenting the part where we calculated the direction towards waypoint. Instead, we now set target within the Boid system so it can calculate all necessary forces that has to be applied to agent and compute velocity for our agents. We will simply read the calculated velocity to move the agents. This way, we are completely delegating the calculation of forces to the Boid system. We will also not be setting the speed value for our agent. Instead, the speed will be needed for calculation in the Boid system, and hence we will be setting the speed value in Boid's component data. We will also be setting the bias values for separation, cohesion, alignment, and target. The perception radius and cell size are used only for hashing. You can watch my previous collision avoidance or Boids video to know more about why Boids are grouped. This is done so every agent needs to only check a limited number of neighbors in its immediate vicinity instead of checking the positions of all agents for calculating final velocity. The Boid system here is calculating the velocity that we need to move the agent. The velocity is continuously calculated to stick to any Boids-based behavior we would want our agents to follow, giving precedence to any one force or balancing them all out. We are also commenting the code to move the Boids here, as we are delegating it to unit movement system. This way, we have separate systems to move, avoid collision, and to navigate. We can now hit play and start adjusting the bias values to get desired behavior. Do note that we should not be pushing the system with say 200 entities in a cramped space, as collision would become inevitable. For this level, with a relatively large min distance value and with agents numbering up to 50, there is fairly good avoidance behavior exhibited by the system. We can even observe separate lanes that form naturally, a common behavior we observe in crowd movement. Play around and you can use it in your systems as well. Let me know what you think in the comment section below, and I'll see you in the next video. Have fun.